Because when we define a green building and this system is that you are designing based on the location. Because if you design a building in Abuja and put it somewhere in Mongolia, they won't perform the same way, right? Because different climate. So the design of a building has to take into consideration the climate, the temperature of 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 the space, right? So the edge app gives walls, shading devices, how this impacts your building, and make sure that these buildings meet that particular threshold Terminola spoke about. So the difference between what you design and what will be the norm in the market, whether your building is green, whether it meets that level 1 standard, level 2 standard, or level 3 standard. Right. So unfortunately, the internet is not too good. Right. We wanted to try our hands. On a you to design a typical office here in Abuja, which is around 10,000 square meters. Looking at the building orientation, right? Because you want to see how you want to shape your building. Looking at the sound part. We look at the window to wall ratio, whether you have insulation for your roof and your walls, whether you have the type of lighting you put in the building, the type of AC systems in there as well, the type of glass, whether it's going to be the double glazed glass or single glazed glass, and now that how that all that impacts your building, the type of flow faucets, right? Whether you have aerators in your faucet and all that, and the type of materials, right? How green are the materials? Somebody talked about the clay walls, which is right. The choice of your material will also impact the cooling demand for your building, all in the way of balancing its flow from one surface to the other, right? So I'll just like to stop here and take any questions if you have any questions. Thank you so much.
I would like to take 2 to 3 questions quickly. I will take them at a go. Can we have the second mic, please? Please raise up your hand if you have any question. Somebody at the edge there, please.
All right, I have our first individual who has a question in white. 1 minute for the question and 1 minute for the answer. Thank you.
My name is Daniel Benjamin from Federal Polytechnic, Nasarawa. You stated 3 factors in green architecture. You are precise about energy, materials, as well as water. And I was concerned with the slide you showed of the student who built, I think, within the span of 2. So my question is, how are we able to raise that considering the green architectural factors?
Do you want to take it? Yeah. You said
Please,
the
you can
building was
take
done
note. We
in
just
2
take the
weeks.
question and answer them at a go, sir.
Yeah. Your question is the building was done in 2 weeks, and how?
Considering the factors, how are we able to build that, considering the...
Yeah. Okay. So now we have different building methods, right? The traditional method will need you to go foundation.
Can we come to this side?
Do
No, not you, sir. Not you, sir.
not me.
Yeah.
Okay. Do a block by block lane, right? But there are different methods so that you can scale the building faster, right? So what they did for this project was to have some formworks, right? So they did formworks, and they had something like an aerated concrete. So concrete with air bubbles. And what does air bubbles do, right? It serves also as insulation, right? So your solid blocks as compared to your hollow blocks, the hollow blocks is going to perform better because that air gap will serve as insulation, right? So instead of having somebody to lay blocks over 1 week, right? Block by block, you can have that formwork and pour concrete in it and just shift the concrete to go to another place and rest. So it's a form of building faster as well and still keeping the sustainability in check.
Thank you, sir. We'll take one here.
Amazing,
To my
amazing.
left. Anybody to my left?
Amazing, amazing.
have a
We have a
question?
gentleman in the hat. Thank you. 1 minute question, 1 minute answer.
Okay, look like your mic is not working. While we're fixing that, I would like to make this announcement quickly. The female architect of Nigeria will be having an intervention visit to IDP camp in Apo. Please, if you are interested, if you are a female architect in the house, you are interested, they are waiting outside for you now. Please just take a walk outside. The bus is waiting. And they'll be leaving any moment from now. Female architect of Nigeria visit to IDP camp in Akpu. Please, can we have the second question now?
All right, we have the question in the house right now. Thank you.
My name is Architect Chuang John. The presenter spoke a lot about his product. And he spoke about energy efficiency. But my question is, he didn't mention the E values and the U values of those materials.
Okay.
Because these are the parameters we use in accessing building materials. They have their maximum E values and U values. And you know the efficiency of a product through its U value.
Okay.
So I would like to know the E of such. Thank you.
So you'll get an answer to that now.
Thanks. Every material, you're right, every material has the thermal resistance, which is the U value, material and a particular U value. The app is able to assess your thermal efficiency based on the U value or based on the R value that the material is as, and that's for the construction material, and it goes beyond that, right? It goes beyond the U values. What are the energy efficiency ratios? What are the coefficients of performance of this material? And even in the material, you don't only look at the U value. You also
Presentation. While the session was ongoing, we have one of our vice president of NIA came into the auditorium. We have in our midst the third vice president, Architect Ali Mukhtar, FNIA. Please.
While we wait for the slide to come up, I thank you very much for giving us this opportunity for us to present our systems. Archibuilt remains one of the best and one of the most respected forum of architects in Nigeria. So it's always a great pleasure to be here, and I'm not taking this for granted. Thank you very much once again. I want to thank the leadership and all the organizers for giving us this opportunity to be here. So we're going to try to be as fast as possible. I have 35 slides to do here today. I wish I can cover it as fast as possible. So we are talking about the efficiency meets elegance, smart ventilation, commercial smart ventilation systems, enhancing architectural design. Please, can I have the next slide, please? Okay, basically, HVAC. We are discussing HVAC today, heating, ventilation, and air conditioning system. That's what it simply means. We are discussing the ability of installing systems that make your enclosures to be conducive for you to exist in it. So you could have, in the winter time, you have heating requirement to make the place conducive. In the summertime, you have cooling requirement to make the system make the enclosure conducive. For the purpose of this presentation, we'll be looking at spaces as enclosures. That is places that are sealed up for people to be in it. So basically, we have two types of air conditioning. That's the systems that requires to make a place conducive. We have the residential air conditioning and we have the commercial air conditioning. The residential air conditioning, just to make it faster, is simply the ones that you have, maybe a split unit mounted on the wall and you have an outdoor unit behind it. Please, next slide. You have an outdoor unit behind it. Please, go back. Go back. Okay. You have an outdoor unit behind it. Just one indoor and one outdoor. The other one is the one you have one outdoor or some outdoors connected to multiple indoors inside the location. So what we are trying to present today is presenting systems that have evolved in such a way that architects will be happy to have them in their enclosures. They make your building look good aesthetically. They are what you want to have in your locations. So we are going to be centering today on the commercial air conditioning, which is the VRF system in particular. Please, next slide, please. The commercial air conditioning here, we are talking about two systems basically, the chiller systems and the VRF system. The chiller systems could be the air-cooled chiller system or the water-cooled chiller system. Then you can also have the VRF system, which is actually means variable refrigerant flow. Variable because the refrigerant that makes the system to cool can be variable, can be released as required by the enclosure. Next slide, please. So now, if you have, I'm trying to introduce technology, how it has advanced now. Technology presently now is such that one system, one particular system installed in a location can be in such a way that some places are made to be warm, some places are made to be cold, depending on the requirement in that location. Some areas, we want them to be warm. Some areas want them to be cold. So you can see in the design, in the drawing here, you have this area with the reddish looking in one system. This is what this system can. Next slide, please. Now, in the VRF system also, you have the mini one, which is used for small locations. Like a small building, you have just a bedroom, two bedroom, a sitting room and all that. You have one outdoor inside, taking care of few indoors inside. So it ranges from 8 horsepower up to 12 horsepower. A simple system, outdoor standing, few indoors. The system is okay from 8 horsepower, from 3 horsepower to 12 horsepower. Why this division between full VRF and mini VRF is simply because of cost. So if I want to have a central system installed in my location, I don't need to go for the higher, the most expensive one. I can take a small one and still get what I want for my location. The technology is still the same. It still gives the variable flow for the refrigerant. It still gives you as you require cooling or as you require heating. So it still gives you the technology, but it's in a smaller space, smaller size. Next slide, please. The other one is a full VRF.